Hello friends, very good afternoon. My good Dr. M.H. Annaya. And friends, in this video, we are going to work out a problem wherein the problem for the isometric projection is given in terms of a statement. Let's see what the question is there in store for today's video. The questions read like this. The frustum of a cone with diameters 30 and 40 with height of 50 rests on the top surface of a rectangular block of dimension they are given. A sphere is placed on the 30 diameter centrally on the top surface of the frustum of a cone. So basically, friends, there are three different objects which are placed one over the other. And first of all, we have at the bottommost a rectangular block or a square block to say it is having dimension 50 by 50 So there is a block here 50 by 50 I written 50 SQ. SQ indicates square and it has got a thickness of 50 On the top of this block is placed what is called a frustum of a cone. So cone is the second part. So the frustum of a cone, that is whenever a cone is cut by a section plane parallel to the base and perpendicular to the axis, the portion below the section plane that is retained is called as a frustum of a cone. It has got a diameter 30 at the top, 40 at the bottom, and height is equal to 50. 40 at the bottom, 30 at the top, 50 is the height. And above this top surface of the frustum of cone, we have a sphere of diameter 30 placed centrally over that. That is to say, the axis of this and that of these all fall on the same line. So, in this basically we are going to learn how to draw the isometric projection of a block, a square block, the frustum of a cone and that of a sphere. So, all the three are there in this particular problem. Friends, let us write down, the dimensions of the, let me start this projection by writing a reference line and let's start with the marking of the block 50 by 50. So friends, I am going to write two lines of length equal to 50 and 50 height. So friends, I am going to have a block here. This is 15 by 15 So since it is at an angle of 30 degrees and it is a square, let's see, 15 we should take first of all. So 15 from here, 15 on this side, and again 15 here. This will intersect at this. Parallel to this edge. So right on the line parallel to that, it has to intersect here. And finally, friends, you are going to have this another line drawn parallel to this. So this is parallel to this, these lines are parallel to each other. And friends, since it is the isometric projection, whatever the dimension you use to construct this figure should have isometric length. So there is a length of 50 millimeter here, and I will say it is iso 50. That is to say, whatever the dimension 50 is there, that is to be multiplied by 0.815. Similarly, this also we have got iso 50. This height is 15 they have given here. Again, that should be iso 50. So when I say 15 iso, that what are the length you have got? That has to be multiplied by 0.815. Friends, you have got this rectangular, sorry, not the rectangle, square block here. This represents the isometric projection of the rectangular block. On that, friends, you have got a frustum of a cone. It has got a circular end and circular top. At the bottom side, it will have what is called a diameter is equal to 40. This is 50 and this is 40 friends. So I will leave 10 mm on all the sides. That is not 10, it is 5 millimeter, because 50 minus 40 is 10. So this gap I am leaving here is equal to 5 millimeter. All these gaps on all the ends. And friends, again, we will take that height of 50 millimeter ISO from all these points. So 50 ISO from here, 50 ISO, all these lines are of isometric line. One from here, one from here, one from this face. This is another height of 50 millimeter. And there, friends, if you draw these lines parallel to this base again, like what we have done, a line parallel here, 50 ISO, parallel to this, then parallel to this line, again parallel here, 1, 2, 3, and this you have to join here, that's all. So we are going to have all these vertical lines drawn through the height of 50 millimeter ISO, and we will join them like this. Friends, you have got here, and all this we are joining by parallel lines, parallel to the edges. Friends, at the top end it has got a diameter of 30 millimeter. So friends, here you have this, and by using 4 center method, one of the easiest method used to draw the ellipse, saving lot of time. And here friends, I am going to construct a ellipse, that is the top end of that frustum of a cone. So what is the procedure, friend? You have to take this as the center, one of the corners, join this to the opposite side corner. So you will have a point here. Similarly, join this corner to the opposite side, center here. Friends, you will get 2 points. This is center 1. With center 1 and radius equal to this much, you can draw an arc. And similarly here, this has center, this length has radius, another arc. This is center C3, and this distance has radius, another arc. This is center 4 with the same radius, another arc. So friends, we have drawn 4 arcs by taking center C1, C2, C3 and C4. This is the construction followed to construct an ellipse, that is by 4 center method. Similar friends, for the bottom face, you have got 40 dia. So this box is having 40 dia. We follow the same procedure. See, we'll join this to the opposite side center, and it will meet somewhere here. So friends, this is our center C1 for this. The center C1 and radius equal to this much, an arc we draw. Similarly, join this to the opposite side center. You get center C2. The center C2 and radius equal to this distance. Draw the second arc. Center C3 with this radius, another arc. Center C4, another arc. So we have drawn two, what is called the center. Here we should have taken 10 millimeter less. So I will have a small change here, friends. Because this has got a diameter of how much? 30 mm. So we have made to 40. This should be 30. You construct. So friends, what do we do here? This is a line here, line from this parallel to that, line parallel to this, and line parallel to that. This has got a dimension of, friends, 40 by 40, but we should have a smaller surface, that is ellipse having 30 mm diameter. So using 4 center method, friends, I am going to construct an ellipse here, ellipse, and then arc like this. So this has got the 4 centers, center C1, radius this much, an arc similar to what we have done here. We have drawn there, friends. Above this, we have got a sphere of diameter 30 mm. So what is to be done, friends? Only in the case of these spheres, we should take the isometric radius as the height. So from here, friends, I will take this height is equal to iso radius. Iso, what is the radius of that? Diameter is 30. Iso ISO 15 radius, means 15 millimeter radius, and with this as the center and radius equal to the actual radius. Once again I am repeating, friends, in case of all spheres in the isometric projection, you have to take the isometric height from the center. After obtaining the center C, we have to take the actual the radius, that is actual radius, and we have to complete or draw a circle through it. Friends, this is how the circle will look. Suppose this is ISO 15 radius. Friends, this is how this sphere looks. Now friends, we have joined all this. Now let us complete the final figure by removing the unwanted line. Friends, when you see here, this sphere is covering this portion of the top face of the frustum of coal. So I have removed. And similarly here, friends, we have got the top face of the frustum, bottom face of the frustum. We have to draw a line tangential to this. A line tangential like this, another line tangential to this. So friends, you have got these surfaces. Let me show this top face by a dark line. So the some portion is behind that. Now friends, similarly here we can complete this part. This is the portion that is visible to you, that is in front. So we'll be able to see that front. So I have shown that by full curve. Whereas the portion behind it, this part, I am going to remove so that you will have a clear picture of the solid. Finally, friends, bottom face you have got, that is the bottom block, a square block. So all these edges are visible. Let me see. So I have to have this. So show a visible line or a full line. This line, full line. This up to here is a full line because the bottom portion is not visible. So this is by a full line, the vertical line, full line. All these three are full lines. And friends, here you can see, friends, we have completed this, and to see that the drawing looks better, we have to remove all these construction lines only after completing the figure. And in isometric projection, generally no dimensions are shown. So I have to have only a small length of this, and no angles are also marked here. So friends, you can simply have this portion retained like this, Remove all these unwanted construction lines, all these, remove this line, and this is the construction line. This portion of the top is not visible. And friends, before I complete this, let me give a final touch with visible lines to this projection. So friends, what I do, I will change this color and say this is a visible line. The thickness of 15 millimeter is so visible, visible, visible. This line is visible. The top face of that visible. The top face of the block is visible. And here, friends, you have this. So this is, I will just to tell you, it is this spear resting on the top face of the frustum of a cone. This is frustum of cone, and this is a square block, rectangular. It's not rectangular, it is a square block because the dimensions are same. So we'll call it a square block. So square having 50 mm by 50 mm. Square block, and it has got a height of how much? 15 millimeters. Friends, let me show all these using the same color. So this is the top face of the frustum. This is one of the generators of that. And friends, this is how the projection of this block will look. Friends, you should also remember the axis of this square block, they will all fall on the same line. That is center of the circle, center of the ellipse, center of this ellipse, and mid height of this block all will fall on the same line. And friends, I am very sure that you have followed the procedure to construct the isometric projection of the combination of solid, wherein you have got a sphere placed on the top surface of the frustum of a cone, which is in turn is placed centrally on the top face of a square block of 50 millimeter side and 15 millimeter thickness and 50 mm side. Friends, by understanding this clearly, you have learnt how to draw the isometric projection of a square block, a frustum of a cone, and then a sphere. Friends, please go through the complete video. Make drawing following the procedure I have told you using the actual isometric scale on a sheet of drawing paper. And then friends, if you like this video, please share the video with all your friends and have a blessed day. I thank you very much for watching my YouTube video.